We're going to use this video to just kind of look at graphs of inverse and reciprocal trig functions, and at the end we're going to talk about some domain restrictions that you'll need to be aware of when you start looking at and solving trig equations later this week. So our tangent function, if we think about tangent is sine over cosine, which means anywhere that cosine is equal to 0, our graph of tangent is going to have an asymptote. So we have these repeated values for tangent, these nice kind of curved lines, and then we have the asymptotes at every interval of pi over 2, because that's everywhere that cosine is equal to 0. So the period of this graph would be intervals of pi. From negative pi over 2 to pi over 2 would be one interval of that graph, and then repeating. For the domain of the function, the domain of the tangent function is everything except for those intervals of pi over 2 that occur every pi, because that's how long it's taking to repeat. And then the range of the tangent function is all real numbers from negative infinity to positive infinity. Secant and cosecant are these U-shaped graphs. They have a period of 2 pi. And you can even think about sketching in a cosine graph in between those U-shaped graphs for the secant, and then the sine for the cosecant. They also have asymptotes anywhere that either cosine or sine, depending on which function we're looking at, would be equal to 0. And then the other thing to notice is that because they are the reciprocal, right, rather than being in the interval negative 1 to 1, they are from 1 to positive infinity and negative 1 to negative infinity. And we can transform all of these functions the same way that we would transform other trig functions. So we can change how often they're occurring, we can shift them to the left and to the right, we can stretch and compress them as well. Cotangent, so the reciprocal of tangent, the graph looks identical other than it's going in the opposite direction for the curves. And then your asymptotes are going to be where the sine function is equal to 0, because cotangent is cosine over sine. So we're repeating still in an interval of pi, but we can't have values that are at pi in the domain. And the range would also be all real numbers. So as we move on to the inverse trig from the reciprocal trig functions, when we think about inverse trig, we use inverse trigonometry to solve for a missing angle measure. So when you studied right triangle trigonometry, sine, cosine, and tangent, and you needed to know the angle in the triangle, you use the inverse trig. So the implication of that is that when we also studied inverse functions, we have to remember that for us to be able to find an inverse function, we need the function to be 1 to 1, meaning that for every output, there's only one input, so it has to pass the horizontal line test. In order for us to do that, we have to restrict the domains in order to be able to use these to solve for trigonometric functions. So arc cosine is another way to write inverse of cosine. We see here that graph is from negative 1 to positive 1. The same thing for arc sine. And then your arc tangent is going to be a little different, because if you think about all of those asymptotes, what we actually do is we're going to limit that to just a single interval in between two of those asymptotes. And these graphs look reflected from our regular trig functions, because if you remember, for inverse functions, we reflect those graphs over the line y equals x. So we're going to look here at the original trigonometric graphs. So for us to be able to find the inverse of sine, we have to limit the graph from negative pi over 2 to positive pi over 2, so that we have all the values between negative 1 and 1, and on that interval the graph is going to be 1 to 1. For cosine, we have to limit values from 0 to pi as we're solving for our equations, because again, we need values from -1 to +1 and for it to be a 1 to 1 function. Tangent is limited from -pi/2 to +pi/2 because that gives it the interval of pi, and in between those two asymptotes, and making sure that we have all of those values accounted for. So this is just kind of a summary of all of that. When you're working and solving equations, if they don't specify which interval that they want you to be working in, we're going to use sine functions between -pi/2 and +pi/2. Cosine, we're going to have angles that are in the interval of 0 to pi. And for tangent, -pi/2 to +pi/2, which gives us correct domain and gives us our correct range. You can also find all of these solutions using some of those interval notations, and we'll look at that more as we get into studying trigonometric equations.